Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be using the epsilon minus delta definition to execute a limits proof. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at this example. Our example says use the epsilon minus delta definition to prove the limit as x approaches 2 of 3x squared minus 5 equals 7. And the first thing that we'll do is go over the epsilon minus delta definition. It says for all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus f of a is less than epsilon. So taking a look at our example, let's identify a few terms here. For the limit that we're given, x is approaching 2, so the a in our definition equals 2. Also, we see that 3x squared minus 5 is our function. And lastly, we're asked to prove that this limit equals 7, so f of a will equal 7. So putting this all together, we need to show that for all epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus 2 was less than delta, then the absolute value of f of x minus 7 is less than epsilon. Now before we start our proof, let's identify a delta that makes this statement true. So we'll start our scratch work or our analysis off with the absolute value of f of x minus f of c. And then we'll plug in for f of x and f of c. So f of x is the function that we were originally given, so that's 3x squared minus 5. And earlier we identified f of c as 7. Next I'll simplify this down to the absolute value of 3x squared minus 12. And then we can factor out 3 here. So 3 times x squared minus 4. And then I'm actually just going to factor out the 3 to the outside of the absolute value altogether. So we've got 3 times the absolute value of x squared minus 4, and x squared minus 4 can be rewritten as x plus 2 times x minus 2. And then I'm going to separate those and give them their own absolute values. And at this point, I'm going to go ahead and say this is less than epsilon. Now, because we know that epsilon is typically an arbitrarily small number, and 3 times the absolute value of x plus 2 times the absolute value of x minus 2 definitely has the potential to become a really big number, we need to put some constraints on that part to ensure that it actually is less than epsilon. The absolute value of x minus 2 isn't really our problem here. It's the absolute value of x plus 2 that has the potential to get really big, so that's where we're going to put our constraint. So let's start off by setting the absolute value of x minus 2 less than 1. If the absolute value of x minus 2 is less than 1, then we can rewrite the absolute value of x plus 2 to be equal to the absolute value of x minus 2 plus 4. At this point, we can move the plus 4 to the outside of the absolute value. And remember, if the absolute value of x minus 2 is less than 1, then the absolute value of x minus 2 plus 4 will be less than 5. Another way to look at this is to let x minus 2 be between -1 and 1. And of course, that's because that's the definition of an absolute value. At this point, we can add 2 to both sides. So that gives us x is between 1 and 3. And so now what does that mean for x plus 2? Well, we just need to add plus 2 to both sides to see. At this point, we see that x plus 2 is between 3 and 5. And what we really want is that upper bound. So moving on, we're going to take 3 times the absolute value of x plus 2 times the absolute value of x minus 2 is less than epsilon. And we're going to start here. And if this is less than epsilon, then that means that the absolute value of x minus 2, first of all, needs to be less than 1. And then 3 times 5 times the absolute value of x minus 2 is less than epsilon. So we just replace the absolute value of x plus 2 with 5. We'll multiply our 3 times 5 to give us 15. and then we'll divide both sides by 15. So we've got the absolute value of x minus 2 is less than 1, and the absolute value of x minus 2 is less than epsilon over 15. So for us, that means that delta equals the minimum of 1 and epsilon over 15. Now that we've identified our delta, we can move on to actually executing our formal proof. Of course, we'll start off with all epsilon being greater than 0. And then we'll let delta equal what we found in our analysis, the minimum of 1 and epsilon over 15. Then for the absolute value of x minus 2 less than delta, we have the absolute value of f of x minus 7. This equals the absolute value of 3x squared minus 5 minus 7. So we're basically just going to follow the work that we did in the scratch work. Minus 12, factor out the 3. Outside of the absolute value equals 3 times the absolute value of x plus 2 times x minus 2. Give them each their own absolute value. And at this point, we know that this is less than delta because we found in our scratch work that delta equals epsilon over 15, and epsilon over 15 is less than epsilon. Hence, we've proven that the limit as x approaches 2 of 3x squared minus 5 does indeed equal 7. And there you have it. We've proven that the limit of 3x squared minus 5 as x approaches 2 equals 7. Now, if this video was helpful for you, give it a thumbs up, like the video, drop a comment down below, and also subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.